today we are going to talk about the time and work problems season 2 problems or episode 2. So first chapter of time and work, we did the time and work basics. This one, then we had another session on time and work problem level 1, where we were talking primarily about the level 1 or foundational problem of time and work. We solve around 10-11 problems in that, and today we are going to talk about the problems that are a level above. And if you see a moderate or a little bit difficult about cat paper, if you think that is going to come in your exam, then these are the problems you can try. These are the type of problems you can try. So we'll try to solve around 6-7 of this problem, so that we cover the entire time and work from the basics to the foundational problem to the advanced level problems. So I will possibly drop the other sessions link in the comment section or somewhere in the I button, and possibly have a look. But without further ado, let's get started. So what we are going to do is we are possibly see a problem, and like in other sessions, what you can do is you possibly pause the video here, see the problem, try to solve by yourself, and then come back and see the solution. That's how we should go about it. If you want to see how I'm trying to solve the problem, you can continue this video without trying yourself. So let's get started. So if you see the first problem for today, which is talks about P is 60% faster than Q, who is 50% faster than R. So P is faster than Q, Q is faster than R. So R is basically least efficient, right? So we can think if R do 1 unit per day, Q is 50% faster than R. So 1 into possibly 1.5 times. So that is 1.5 unit per day. And P is 60% faster than Q. So that means 1.5 into 1.6. That is 2.4 unit per day. So that is the individual capacity. U is 50% faster than R. So if R do 1, Q do 1.5. P is 60% faster than Q. So if Q do 1.5, P will do 1.5 into 1.6, which is 2.4 unit per day. Now they said to complete a work, P takes 30 days less than Q, right? And Q and R start the work, they work for 24 days. If P took over from them, how many days it should be completed? So if we see, basically, P takes 30 days less than Q, right? So they said P takes 30 days less than Q. So this is the actual chunk where you are actually try to, because these are our assumption. R does 1 unit, Q does 1.5 unit, P does 2.4 unit. This is P takes 30 days less than Q. That is the basically clue of the problem, from where you will try to get the absolute value for this problem. So let's say P takes 30 days less than Q. So obviously the total amount of work should be same. So let's say Q takes X days to finish the work. P will take X minus 30 days. So in X days, Q will do 1.5X. This should be equal to, total work should be same, right? So total work done by Q in X days is 1.5X, because 1.5 unit per day. Similarly, total work done by P should be 2.4 into X minus 30. So if we just simplify this, you will see, we'll get, so this should be 72 should be equal to 2.4X minus 1.5X, or we says from here we can say 0.9X is equal to 72, or we can say X is equal to 80. So Q takes 80 days, P will take 50 days. So Q takes 80 days. Can we then finalize the total work? So the total work was 1.5X, or you can take either this equation or this equation, both are same. So 1.5X, so 1.5 into 80, or we can say 120 unit. So 120 unit is the total amount of work. Now out of that, Q and R start the work and they work for 24 days. So Q plus R in 24 days can do how much? Q and R in one day can do 1.5 plus 1, that is 2.5 into 24. So 2.5 into 24 is 60 unit. So left is how much? 120 minus 60, or we can say 60 unit is left after Q and R work for 24 days. P took over from them. So that means after 24 days, only P is working. So P in one day can do 2.4 unit. So 60 divided by 2.4. This should give you, which will just do 60 into 10 by 24. So 25 days. In how many days the work gets completed? So P takes 25 days, but remember they said how many days the work gets completed. So 25 days P will take. The total days should be 25 plus 24, 49. So after Q and R left after 24 days, P will take 25 days to finish, and then total days is 49 days. It's clear. So basically we are assuming what is the individual units based on the capacity efficiency given. From there, the condition that is given to us, actually the crux of this problem is P takes 30 days less than Q. So from there, you kind of try to assume what is the total amount of work, what is the total number of days kind of they will take. And from there, I'm trying to assume what is the total work. Once I get the total work, I know individual capacity. From there, I will be able to get the value. So that's how we do it. Hope it's clear. Let's move to the next one, see what is being said in the next one. Okay, it's visible. So if 60% of a certain quantity of a work is done by P, after that 40% of the remaining work is done by Q, then the work will get completed in 12 days. 40% of the work is done by P and 60% of the work is done by Q, then the work will get completed in 15 days. What is the total individual time? Okay, so here let's say the total work, because I have to find the percentage of work, let's say total work is 1. Okay, so P in one day can do X unit, Q is the other one, right? Yeah, Q in one day can do Y unit. So basically, I'm just assuming the individual capacity because there is no relation between P's per day and Q's per day. So I'm not getting the values individually. What I'm trying to get is total work is 1, or you can consider 100. Both should be same. So if you think do 100 unit, the total work is 100 unit. Okay. So 60 in the first case, 60% is done by Q. So 60 unit will be done by Q. So in one X unit done in one day. So 60 unit will be done by running 60 by X days for P, right? 60 by X days. And the second one is 40% will be done by Q. So 40 by Y days. 40 by Y, because Y unit you are doing in one day. So 40 unit will be done by 40 by Y days. So this should be equal to 12. That is your equation 1. Similarly, I can write 40 by X in the second scenario plus 60 by Y should be equal to 15. This is your equation 2. So if I add 1 and 2, you typically get 100 time of 1 by X plus 1 by Y equal to 27. Let's say this is equation 3. I'm just adding 1 and 2. Now, so you see there are two variables and there are two unknowns. Obviously, it's tough to solve this way. Let's see how we can solve this. So if you see typically, then there is also another inherited equation is given to you, because if you see the first problem, they said 60% of the work gets done by P and 40% of work done by Q. You are taking 12 days. Next case, you just reversed it and it is taking 15 days. So out of 100 unit, so that 20% of work that was P doing in the first time versus Q doing in the second time. So basically, first time P is doing 60, second time P is doing 40. First time Q is doing 40, second time Q is doing 60. So in this case, the second time, the extra 20% of work that P is doing or Q is doing, it is taking 3 more days. So can we say 20% of work by Q minus 20% of work by P should be equal to 3 days. So that's what is creating the 3 days difference, 12 days, 15 days. 3 days extra because the 20% of work is done by Q. That is where it took time. So let's say the first 100 unit, so 0 to 40 unit is first case 60 unit done by P, then the last 40 is Q. What is here is first here consider that 0 to 40 is done by P, but Q in this case doing 40 to 100. He was anyway doing 60 to 100 in the earlier case. Now he is doing 40 to 100. So that 20 extra that is done by Q in the second case, which was done by P in the earlier case, that is where the difference is created. 0 to 40 was previously done by P, now it is also P. 60 to 100 previously done by Q, now also done by Q. The only difference that is getting created is because of between 40 to 60. Earlier P, now Q. So that's where it's created. So 20% of the work. So basically 20 unit. So can we write 20x minus, or it should be ulta because 20y is more because Q is taking more number of days. 20 by x, and you have to be a little careful on writing this equation because Q is taking more number of days. So 20 by y should be a higher value. So y unit in 1 day. So 20 unit will be 20 by y day. This should be equal to 3. So if I, yeah, that's what the 30 unit. So if I do 20 into 1 by x minus 1 by y, that is equal to 3 by 20. Let's say this is equation 4. So you have 3 equation, you have 4 equations. So if you can solve this, so basically I can write them 1 by x plus 1 by y, 27 by 100, 1 by x minus 1 by y, 3 by 20. Sorry, this is not 1. This is 1 by y minus 1 by x. So just a minute. So this is 1 by y minus 1 by x is equal to 3 by 20. Okay, now from here, if I just add these 2 equations, I'm just adding these 2 equations. So then this will become 2 by y is equal to 27 by 100 is 3 by 20. So 27 plus 15 by 100, 5 times, so 42 by 100. Or from here we can find out just reduce it a little. So we can know 2 by y is 42 by 100. So from here I can write 1 by y is 21 by 100. Now we can say y equal to 100 by 21. Y equal to 100 by 21. So so that similarly you can find out x. So I'll just first show y. So q, so basically I'm saying q in do 100 by 21 unit in 1 day. So q will do 1 unit in 21 by 100 days. So q will do 100 unit in 21 by 100 into 100 or 21 days. So q you can calculate like this. Similarly, if you put the value of y, you in the any of equation 3 or equation 4, you should get the value of x, right? And from there you can easily calculate. So I can quickly show you. So if y is 100 by 21, I can write 1 by x plus 1 by y is 21 by 100 should be equal to 27 by 100. I'm just using equation 3. So 1 by x in this case is 6 by 100. So if 6 by 100, you again put the value in the similar way that we have done, and then you can see you can do the work in 6 days. So for y was 100 by 21 and x is in this case is 100 by 6. So p will take 6 days. The same approach that we calculated here, how q, same way you can calculate for p. So p will take 6 days. And that's how the work is done. So basically, whenever a typical type of problem is there, see what you can assume. Here there is no relation between p's efficiency and q's efficiency, or so that's why we did not assume individual values of per day work done, but we have assumed the total unit, and then from the total unit we kind of distributed and formed these two equations and solve this. This is clear. Let's move to the next one. Okay, so they said there is a group of person, each of whom can complete a piece of work in 63 days. On the first day, one person, second day, another person. So group of person, each of them can complete a piece of work in 63 days. So in one day, each of them can do 1 by 63. So in day one, there is in day one, there is one person. In day two, they said in the second day, another person joins, 2 person. On day 3, 2 more person joins. So day 3, 4 person. Day 4, there are 8 person, right? And similarly, it goes on. So in first day, the work done is 1 by 63. Second day, the work done is 2 by 63, because each people do 1 by 63 in a day. So day 3, the work done is 4 by 63. Day 4, the work done is 8 by 63. So if you see, typically, if the total work is 1, and let's say I'm doing it till 4, so 1 by 63 plus 2 by 63 plus 4 by 63 plus 8 by 63. So the moment I can say my numerators 1, 2, 4, 8, this sum becomes 63, my total sum becomes 63 by 63, which is equal to 1. So this is nothing but what? 1 by 63, 1 plus 2 plus 4 plus 8 and so on. So as soon as this sum becomes 63, my total work is done. 63 by 63 is total unit. Okay. So from here, so I can say from here is 1, 2, 3, 4, 7, 15. So day 5, there will be 16 folks, right? In day 6, there will be 32 folks. So 16 means 16 by 63. 32 means 16 by 63. Sorry, 32 means 32 by 63. So 1, 2, 4, 8 plus 16 plus 32. You see, this sum becomes 63 by 63 or 1. So basically, day 6 is the day when your work is completed. So total 6 days is needed to finish the work. Right? Cool. So let's move to the next one. They said there are 3 men, A, B, C, working together can do a work in 30 days. They start a work together. A work for 3 days, take a rest day. So it's a very good problem. If you see, it's not linearly they are working. So they are working, they are taking rest, they are working, they are taking rest. So it's a pattern. So for A, I can say A is working, then taking a break, then again working, then taking a break, right? So can I say A is 3 working in 4 days? So basically for A has 3 working days in 4-day period. In any 4-day period, so if I take this 4-day period, A has 3 working days. This 4-day period, A has 3 working days. So A has 3 working in 4 days. Similarly, if I read B, B is saying 5 days and take rest on the next 2 days. So B has 5 working days in 7 days. Similarly, C, 7 days working, 3 days rest. So 7 working days in 10 days, right? So if I, for A, if I take a 4-day period, each of the 4-day cycle, A is working 3 days. For B, if I take a 7-day cycle, B is working 5 days. For C, if I take a each 10-day cycle, C is working for 7 days. Okay. Now they said A, B, C work at the same rate. So let's say both of them work for 1 unit, 1 unit, 1 unit per day, right? Together, if they work, they can finish the work in 30 days. So that means A plus B plus C into 30, which is 3 into 30, or can I say 90 unit is the total work, right? So here you just need to do a trial and error. You have to see how many of the cycles. So let's say, and we'll try to see how much we can get closure. So how we do that? So one option is you can go by options, but if you don't have the options, you can possibly try. So let's say a 10-day period, a 10-day period. In 10 day, A has two 4-day cycle plus 2 working day. That means A will do in each 4-day cycle, A has 3 working day. So that means A will doing 3 unit in each 4-day. So 2 4-day cycle means 3 into 2 unit plus 2 days. That means 2 units. So A is doing 8 unit. B is having one 7-day cycle plus 3 days, 3 working days. So one 7-day cycle, B is doing 5 unit, 5 plus 3, 8 unit again. For C, in a 10-day period, it has only one 10-day cycle. So in each 10-day cycle, C does 7 unit. So C does 7 unit. So in a 10-day period, I can say A plus B plus C is 8 plus 8 plus 7, 23 unit, which is very far. So if I take out of 10 days, A plus B plus C can do 23 unit only, where my total work is 90 units. So I have to go a lot. So if I take a 10-day period, obviously that will not be the same for the 10 to 20 because the cycle will change. So, but overall, if I think average on a 10-day period, BC can do 23 unit. So what I have to do is you possibly see 90 unit is possibly 3 times higher. I'm not saying that exact 23 unit being get done in each 10-day cycle, but overall you can see total is 90. This is 23. So possibly at the 4th 10-day period is something we need to look at for getting closure. For that, let's try to do it for a 40-day period. If I say a 40-day period and see this carefully, A is A. Now A has how many 4-day period? A has 10 cycle of 4 day. So in each cycle of 4 days, A does 3 unit. So 10 into 3, 30. B, the 7-day cycle. So I can say 5 cycle of 7 days plus 5 days. So 35, 5 cycle of 7 days. So no, so for each cycle, B is doing 5 unit because he is 5 days of working. So 5 into 5 plus another 5-day working. So again 30 unit. C works at a 10-day cycle. Out of that, he is in a 10-day cycle, C does 7 unit. So C has 4 cycle of 10 days. So 4 into 7, 28 unit. So in a 40-day period, I can see A plus B plus C is 30 plus 30 plus 28. Total is 88 unit. Okay. So this is possibly the closest I can do by 90 unit. If you now think who works on day 41, I just have 2 unit left, so I need 2%. If you see 40-day period, A has finished a complete 4-day cycle. So it will start another cycle as a 41st day for A. So A will surely work. If I see B, B has finished 5 7-day cycle and finish another 5 working day. Now it's time for B to take rest because B has worked 5 7-day cycle, which is 35th day and 36, 37, 38, 39, 45 days B has worked now. So 41st day should be a rest day for B. So B will not be there. For C, again, C works at a 10-day cycle. So 11th day, C should work. So similarly, 40th, in that 40th day, 1 10-day cycle is over for C from 30 to 40. So that cycle is over. So 41st day, C will again work. So day 41, A plus C will work and 1 plus 1, 2 unit will get done. So that means 41 days will be needed to finish the 90 unit of work. So it's a very good problem where you see we have tried to draw a pattern. So there's a one for 3 days, 1 day rest, 5 days, 2 days rest, 7 days, 3 days rest, and they started simultaneously, right? So you can't basically say for a 10-day period, typically this many people are working, right? So that's how we go about it, because if you see it's not linear. So if I see first 10 days 23 unit of work was done, but in 40 days it's not 92, 40 days it's 88, because the cycle will vary. Okay, for the first 10 day 11th day A and C will work. I think possibly A and C will work, not 10 C, because B will also work. So you have to see it's not 11th day pay, always A and C will work. Like for 41st day, I can see A and C is working on 41st day, doesn't mean on 11th day also A and C will work. You have to see who is coming on that cycle. So you have to be a little cautious. It's not linear, but that's how you can possibly frame an idea. That's why I started with 10 and possibly frame an idea. If you have options, you can possibly try with the options. Try possibly choosing an option which basically a break. So let's say you have 4 options, 37, 38, 40, 42. You possibly choose 42 because that's easy, 40 easy to calculate. And then you see 40 pay if you are doing 88 unit, and that means the other two cannot be the answer. Possibly is 41 maybe. So then other two cannot be the answer, because 40 at the end of 40 days, if you're doing 88 units, at the end of 37 or 38 day, you cannot do possibly the 90 unit. So it should be something higher than that. So that way you can go about it. But yeah, so what we're seeing, each of the problem that we have chosen, it's not one approach that works. You possibly need to understand what is given to you, what you can, what should be a starting point for the problem. Is there a pattern? Is there some relation about efficiency? Is there some relation about possibly create an equation? So we have seen different type of problems, which is very important when you are doing a level 2 or level 3 kind of a problem. Let's move to the next problem. So it says a certain number of taps fill a tank in 7 hours. This should be a straightforward one. So if there were 4 tap slips, the tank would have taken filled by 11 hours. So let's say there is a tank which has full capacity. Let's say L liter is the full capacity of the tank. Okay. And a certain number of taps, let's say you have number of taps equal to n, and fill tank in 7 hours, and each tap kind of work equally you can think of, because it's not said that they are not equal. So similar type of tap. So each tap, let's say x liter per hour. So can I say then n taps for each tap x liter per hour? So for n taps it will be nx liter per hour. working for 7 hours can fill the tank. So nx into 7 should be equal to L, the total. Similarly, if you have 4 taps left, so n minus 4 x, then they are saying 11 hours, so 11 equal to L, right? So let's say this is equation 1, equation 2. You just do 1 divided by 2. You get 7nx by 11 into n minus 4 into x is equal to L by L. So n, sorry, not n, x gets cancelled, L gets cancelled. So I can write n divided by n minus 4 is equal to 11 by 7. Or from here I can write 7n, 11n minus 44, or if I'm 4n equal to 44, or n is equal to 1. So they started with 11 number of taps, option B. Okay, possibly a straightforward one, but what I want you to think why I choose this problem is you possibly need to think how to form an equation. When there are less information, you possibly need to assume things and try to frame an equation and solve that. It's not every time you have a paragraph kind of a so description given to you from where you can solve it. Let's see the last problem for this session. This is a very important problem. I've seen this in multiple forums, in multiple mock CATs, and I think that this is also came in CAT 1 forward the year. So they said a fill pipe can fill a tank in 20 hours. A drain pipe can take 30 hours to drain the tank. So again, go to the basics. So LCM of 20 and 30, because you know this will not. So this is, let's say, 60 liter. So let's say the tank's capacity is 60 liter. If this is the total tank capacity, can I say you need 3 inlet pipe to fill, or you need 2 a pipe can fill a tank in 20 hours. So basically you need 3 inlet pipe and sorry, so they said the total is 60 liter. So if your a tank is, so basically, okay, let's do a little simpler one. So if the total is 60 liter of the capacity, a fill pipe can fill the tank in 20 hours. So for inlet pipe, 20 hours means typically 3 liter per hour. For a outlet pipe, it is 2 liter per hour. Obviously it's a minus, or it kind of goes out. So can I say 2 inlet pipe completely nullifies the work of 3 outlet pipe? How I come to this? Because they said 2 inlet pipes capacity will be 6 liter, 3 outlet pipes capacity will also be 6 liter. So if I have, so here they have talking about a combination of pipes. The volume is a system of n pipes, fill pipe and drain pipe together. So if I say there is a combination of 5 pipes, out of which we have 2 inlet plus 3 outlet, the output will always be 0, because 2 inlet pipe completely nullified by 3 outlet pipe. So if I have a set of pipe or number of pipe which is possibly multiple of 5, so let's say 5n, out of which I have 2n in terms of inlet plus 3n in terms of outlet, the tank will never get filled, because with 2 inlet pipe, how much ever you are filling, with 3 outlet pipe, I am taking out the entire thing. So basically, you can't have, you possibly need something more. So now if you see, typically they said the tank needs to get filled in 5 hours. So if they say the tank basically needs to get filled in 5 hours, so in 5 hours you have to fill up 60 liter. So in 1 hour you possibly need 12 liter. 12 liter means, if I just consider inlet pipe, you need 3 inlet. So now can I say when there is a combination of n pipe, that should be a combination of, sorry, not three inlet, I need four inlet, because each inlet do 3 liter per hour. So basically for 12 liter per hour, I need four inlet pipe. So can I say I need a combination of 5 n pipe, which is the inlet plus outlet, plus 4 inlet pipe. So this should be your information. So if you see what all the values that satisfies the equation, 32 is not in a 5n plus 4 format. The 5n is 30. 54, yes, 5n plus 4 format. So 54 can be your answer. 54 can be your answer. 29, yes, again 5n plus 4 format. So 5n is 25 and then plus 4, 29. So this can be your answer. 40 is exact 5n, so it does not work. So both of these 54 and 29 can be your answer. So what we are trying to do here is we are creating a combination of pipes first, which kind of nullify each other, and then see how much extra of which pipe we need to fulfill the tank in 20 hours, right? Or in 5 hours, sorry, 5 hours. So to fill the tank in 5 hours, I typically need uninterrupted 4 inlet pipe, whose work should not get nullified. But there are also outlet pipe also. It's because the total number of n pipes is a combination of inlet and outlet. So I possibly need to think of a combination where there are inlet and outlet. So first I will think the number of outlet pipe, and then I should have the number of inlet pipe that will nullify the effect of the outlet pipes. So it's always in a 2:3 format. So basically, if there are 3 outlet, I should have 2 inlet. So I have a combination of 5 inlet outlet pipe. They will nullify each other. Then I will give 4 completely dedicated inlet pipe to fill the tank in 5 hours. And that's how we do it. A very good problem. I hope you learn some of the thinking process, how you should go about it. And that's how we solve some of the 11th problem. So if you have any further doubt, I will drop my mail ID in the description box. You can reach out to me if you want kind of a one-on-one support from me or guidance from me. You possibly drop a mail. Otherwise, go through the basics and the first part of fundamental problems on time and work, which are relatively simpler, but strengthen your foundation. And from there, we do this. So possibly for next class, we will pick up another topic. But yeah, do reach out if you need any guidance from me, or if you need a one-on-one session with me, please reach out in the mail ID, and we'll take it from there. It's in the description box. Thank you. Have a nice day. Bye.